So, we are graphing linear equations and inequalities today. Remember, an equation has an equal sign, and an inequality is either a greater than or less than, or greater than, less than, or equal to. But I have a couple definitions for you guys before we get started. The first definition is y-intercept. A y-intercept is a point where the graph crosses the y-axis. So it's intersecting the y-axis. We also had two different forms of a line. The first one was slope-intercept form. And if you guys remember all the way back from Algebra 1, slope-intercept form was like our favorite form. It was y equals mx plus b. Do you guys remember that? It should at least sound familiar. Y equals mx plus b. M is the slope, and b is the y-intercept. And the reason why we like this form so well is because this one is really, really easy to graph. There's no extra work involved. Everything is just laid out there for you. If x and y are on the same side of the equal sign, it's called standard form. So in this definition, ax plus by equals c, a, b, and c are all going to be numbers. X and y will still be there. So if x and y are on the same side of the equal sign, it is called standard form. And then just like we have a y-intercept, we also have an x-intercept, which is the point where the graph crosses the x-axis, which should make sense. Okay, so how do we graph an equation when it's in slope-intercept form? Remember, that is y equals mx plus b, okay? So slope-intercept form is y equals mx plus b. First step is kind of silly, but sometimes it will ask you to graph in a specific way. It says write the equation in slope-intercept form by solving for y. Basically, if it's in y equals mx plus b form, you're good. So then our next step would be to identify the y-intercept, which is b, and plot the point where the line crosses the y-axis. So your y-intercept is going to be right on the y-axis. Step 3, you're going to identify the slope, which is m, and use that to plot a second point on the line. And remember, you're not starting from 0, 0 when you're counting the slope. You start from the point you already made. Okay, so from the point you already made, you're going to make a second point. And then 2 points is good enough, so you're going to draw a line through both of those points. Okay, so we are going to graph this line, y equals negative 3 over 2x plus 1. The first step was to get the equation slope-intercept form. This one is y equals mx plus b, so we're good there. So then our next step would be to find the y-intercept. The y-intercept here is negative or positive 1. So on your graph, starting at 0, 0, you're going to go up 1 space because that's along the y-axis, and put a point there. Now our slope is going to be negative 3 over 2. Now remember, when our slope is negative, slope is rise over what? Run, good. But which one do I attach the negative to? Both of them are not negative, just one of them is. It doesn't matter. You can do the top or the bottom. I always attach it to the top because it's just easier to remember. So I always make the rise negative, and then that way the run is always positive, okay? But both of them are not negative. Just one of them is. So what I want you all to do is please put your pencil on the point that we just made, that y-intercept. And our rise is negative 3, so I want you to count 3 spaces down. Do not put a point there yet, because we still have to count the run, which is 2 spaces to the right. So to the right now, count 2 spaces. And you should put a second point right there. Put a line through it, and you're done. That's why we like slope-intercept form. There was no math involved in this one. You just had to identify each of the points. It makes graphing really, really fast. Now, if your equation is not in y equals mx plus b form, it's also not a ton of work. So I'm going to show you the steps for that, and we're going to do an example for that one. Okay, so if our equation is in standard form, meaning x and y are on the same side of the equal sign, then you're going to be following these steps. Same thing, step 1, make sure it's in standard form. Step 2, we want to identify the x-intercept and plot it, meaning that our point is going to be right here on the x-axis. So to find the x-intercept, you're going to plug in 0 for y. Step 3, you're going to identify the y-intercept, and the y-intercept is where we cross the y-axis. So you are going to plug in 0 for x, and that gives you your 2 points, so you can draw a line through it. So example 2, we're going to graph 2x plus 3y equals 12. If you guys notice, this x and the y are on the same side of the equal sign. So this is not y equals mx plus b form. This is standard form. So the way that I do this to help organize my work, I make a T-chart, and I label one side x-intercept, and I label the other one y-intercept. This just helps me to keep my work separated so that when I look back, I know exactly what it was that I was doing. So when we want to find the x-intercept, that's where the graph is crossing the x-axis, which means y is equal to 0. So looking for the x-intercept, we plug in 0 for y. So what I'm going to do is I have 2x plus 3 times 0 gives me what? 0. So that's going to be plus 0 equals 12, which is 2x equals 12. So x equals what? 6. So as soon as you get x equals 6, I want you guys to plot this. So along the x-axis, go to the right 6 spaces. 1, 2, 3, 4, 5, 6. Okay, that's your x-intercept. Have any of you heard of the cover-up method? Okay, the cover-up method is saying that because I plug in 0 for y, that 3y totally went away, correct? If you guys notice, we could have covered up 3y, and what would we have been left with? 2x equals 12, which is what we ended up with anyway. The cover-up method is like a shortcut, so you don't have to write this step right here where you have the 0 in there. So let's try that on the y-axis. So to find the y-intercept, which one would I cover up? The x's. So when you're looking for the x-intercept, you cover up the y's. When you're looking for the y-intercept, you cover up the x's, and I would be left with 3y equals 12. So that's how we're going to find the y-intercept. 3y equals 12. And the reason why we can cover them up is because if 3y equals 12, what does y equal? Good. So this is the y-intercept. This is not a single point. This green one is the x-intercept. This blue one is the y-intercept. They are 2 separate points. So along the y-axis, I want you to graph 4. That's 2 points. That's good enough. So go ahead, draw a line through it, and you're done. Okay, so special cases of lines. We have horizontal lines and we have vertical lines. A horizontal line means that it is going left to right. So it looks like this. And occurs when you have y equals some number. So y equals a number is a horizontal line because it's crossing the y-axis. So if you have no x and you just have y equals a number, we're crossing the y-axis. So it's going to be a horizontal line. Okay? If we have just x equals a number, no y's, we're crossing the x-axis, which is a vertical line. Okay. So example 3, we're going to be graphing two special lines. The first one is going to be y equals -1. I'm going to do that line in orange, okay? So normally you'll just be asked to graph one line on a graph. I'm just putting both on one graph to save us space, okay? So part A, we want to graph y equals -1. Because this is a y equals and there's no x's in there at all, I know that I'm going to be crossing the y-axis. So what you want to do is put a point at the y-intercept at -1. So because it's just y equals -1, put a point there and draw a horizontal line through it. So we are crossing the y-axis when you have y equals a number. Part B, I'm going to do that one in green. We want to graph x equals 2. So there's just an x here. There's no y's, meaning we're crossing the x-axis. So we're going to put a point through the x-axis at 2. And in order to cross that point, we need to draw a vertical line. So it's all about which way we are crossing. So when you have a y by itself, in order to cross the y-axis, it has to be a horizontal line. Otherwise, it's not going to cross the y-axis. If you have x equals a number, it's not going to cross the x-axis unless it's a vertical line. So you're going to only be graphing a horizontal or vertical line if you only have a y or an x. Okay? Okay, so I want to define for you what is considered a solution of an inequality. A solution is any ordered pair that makes the inequality true. So remember how all the way since, I don't know, elementary school, they tell us to check our answer, you plug it in? That's what you're going to be doing here. So basically, they're giving us an answer, and we need to check if it is a correct answer or not. So in example 4, I'm giving you one inequality and 2 points. And we're going to check to see if both of those points are a solution. Okay? Okay, so A, let's check if this is a solution. What we're going to do is we're going to plug in one of the numbers for x and one of the numbers for y. Which one is going to be plugged in for x? 3, because it's in the x coordinate. So this is going to be 4 times 3 plus 2 times y, which is 2. And we want a statement that is greater than 6. So let's do the work. 4 times 3 gives me 12. That's a weird 2. Plus 2 times 2 is 4, greater than 6. And 12 plus 4 gives me 16. Is 16 greater than 6? Yes. So yes, this point is a solution. And remember, inequalities can have more than one solution. So just because this point is a solution, there's infinitely many other points that are also solutions, because it's anything that makes the equation bigger than 6. Okay, so what I want you guys to do is try -1, 4 and tell me if it is or is not a solution. Okay, so for B, what did you guys plug in for x? Good, -1 plus 2 times, what did you plug in for y? Excellent. Greater than 6. Okay, 4 times -1 gives me -4 plus 8, greater than 6. What's -4 plus 8? 4. Is 4 greater than 6? No. So is this point a solution? Nope. Okay. All right, guys, so to graph inequalities. The nice thing about graphing inequalities is that you actually graph the line the same way that we did earlier at the beginning of the notes. So your first step is going to be graphing the boundary line the same way as an equation. So you're graphing the same way as an equation. The only thing that's different is that your line is either going to be dotted or solid. Now, how do you know? Remember yesterday when we were graphing on the number line, and if there was an equal sign, you got to put a solid point, but if there was no equal sign underneath, you build a fence around the point and it has to be an open one? Same idea here. If you have an equal sign underneath your inequalities, so greater than or equal to or less than or equal to, you're going to have a solid line because you can touch it. If your line is greater than or less than, it's going to be dotted or dashed because you're building a fence around it. You cannot touch that line, okay? With inequalities, because we have infinitely many solutions, you're going to shade the region above if you have greater than or equal to. There we go. Because we're looking at everything bigger than the line. So if you're greater than or equal to, anything above the line is a solution, so you're going to shade that whole thing. If you have less than or equal to, you're going to shade below because our answer is anywhere underneath that line. And then the last step is going to be to check your answer by testing a point. If you test a point and you get a true statement, then you shaded the correct area. Okay, so example number 5. I want you to graph y is less than or equal to 3. Now, when you're looking at this example, guys, what's the first thing you notice? It's only 1 point. There's no x's, right? It's just a y by itself. So because it's just a y, I'm remembering that that's going to cross the y-axis. So at the point 3 across the y-axis, I'm going to draw a horizontal line. Now the thing I have to worry about, though, is this line going to be solid or is it going to be dotted? It's going to be solid. How do you know? Who said it? There's an equal sign underneath it, right? So because there's an equal sign underneath, it's going to be a solid line. Now our inequality tells us that any y less than 3 is going to be an answer. Where are the y's that are less than 3? Are they below the line or are they above the line? Below. Below. Everything below the line is 1 or 2, 1, 0, -1. They're all getting smaller. So you're going to shade below the line. And to shade, I always just do a bunch of lines. So we have a solid line because our inequality was less than or equal to, so that means I can touch the line. And since we're looking for everything less than, it's everything that's below the line. Anything above the line is not a solution. So if we were to pick any point in that shaded area and plugged it in to the inequality, we would get a true statement. Okay? Okay, example 6 wants us to graph y greater than -1/2 x plus 2. Is this y equals mx plus b, or is it x and y on the same side? Y equals mx plus b. So let's graph this really quick. My y-intercept is 2, so put your y-intercept at +2. What's my slope, guys? Excellent, -1/2. So, from your y-intercept, put your pencil there. Rise is -1, so you're going to go down 1 space. Run is 2, so you're going to go to the right 2 spaces, and then put a point. Two points is good enough, so we're going to put a line through it. Now my inequality is just greater than. There's no equal sign, so what kind of line should I have? Dotted. It's like barbed wire. Since there's no equal sign, you can't touch it, so we have to draw a dotted line. These dotted lines are really hard to draw straight. Okay, so there's my dotted line. Greater than means I'm shading which area, above or below? Above. And that should be logical, right? Anything greater than is above. Anything less than is below. So shade that area. And that's it. Example 7. We have 2y minus 3x is greater than or equal to 6. Now, is this y equals mx plus b, or is this one x and y on the same side? X and y on the same side. So what you're going to do is, I always draw a t-chart. And we have our x-intercept and our y-intercept. To find the x-intercept, I'm going to cover up the y's. So that's going to leave me with negative 3x equals 6. When I divide both sides by negative 3, I get x equals negative 2. So let's plot the x-intercept right now at negative 2. It's right there. So far, so good? Okay. To find the y-intercept, I cover up the x's, so that leaves me with 2y equals 6. Divide both sides by 2, and we get y equals 3. So I'm going to go up from 0, 0, 3 spaces to find my y-intercept. Okay, so my inequality is greater than or equal to. So is that going to be a solid line or a dotted line, guys? Solid. And greater than or equal to means that I'm shading above. And you're done.